So we've got force problems. This is a quick little intro one, and then I'll do a more legit one. What is your mass in kilograms? So a lot of the times for this force unit, we're going to do the relationship between force, mass, and acceleration. So if we take, and sometimes that involves conversions here, but if we take what we would weigh in pounds, and you can use any numbers you want here. You can just copy my example if you want to, but if you really want to know your mass, this is how you can find it. You can also check it with a scale here, which I'll talk about at the end here. So weight, for the variable weight, instead of W, we're going to use Fg. So we're going to convert, so this is going to equal, which is called the gravitational force. We're going to convert this weight to newtons first. So you take 170, pounds. And there's 0.225 pounds in 1 newton. If we take that in the calculator, we get an a gravitational force, a weight of 756 newtons. Now, how do we get that force to a mass? Well, the relationship between force, mass, and acceleration is specifically sigma F equals ma. And then we're always going to ask ourselves, well, what is this net force that I want? Well, that's my weight. That's the gravitational force in this case. Mass will always be mass. If there's two masses, you add them together. Mass is relatively straightforward. Acceleration in this case is due to gravity. So we're going to change that to g. So if I take my 756 and set it to equal m times 9.8, now here's where we need to be careful. Gravity we define as a down. So we are going to make that negative, which then would give us a negative mass, which can't happen. Mass is how much stuff makes you up. It's not a negative. It doesn't have anything to do with direction. But your weight, gravitational force does. You are getting pulled down by gravity. So this 756 is also negative. So when I take those two numbers, the negatives cancel out, and what will be left is my mass in kilograms, which I get 77 kilograms. And you can check it with a scale. Some scales have it built right on the dial. If it's a digital scale, there's a switch on the bottom where you can flip it over to kilograms, and it'll convert it for you. You can verify it if you want to. Let me talk about units real quick. How did I get force units and acceleration units to turn into kilograms? Well, force is a newton, right? Force is equal to 1 newton, which is really a kilogram meter per second squared. So I had a kilogram meter per second squared on one side, and I divided by 9.8 meters per second squared. So when I divided this by meters per second squared, it canceled out the meters per second squared, and you are left with kilograms just to check out the mass there. All right, next question. So typically, if we are lifting something, we will have to do that weight calculation. That'll come second nature once you've done a couple of these. So for this one, how much force in pounds is required to lower a 2 kilogram physics book off a desk with a downward acceleration of 1.5 meters per second squared? So we're going to draw a free body diagram. Again, to help us set this up, we got a book, and we're not dropping it. If we were just dropping it, you would have this. You'd have a gravitational force downward, and then that would be it. But we are applying a force upward to keep it from falling. How much force is required to lower it? So that is what we were looking for. Fg is going to equal mg. So variable wise, we're looking for Fa. We know our mass is 2 kilograms. And then the acceleration is 1.5 meters per second squared. So where do we start with these? You're always going to start with the same thing. The second you see a force mass acceleration, it's our sigma f equals ma, and that's acceleration a. And then you're always going to ask yourself, well, what is sigma f? How much? And all that means is, what are the total forces acting on us that are causing this acceleration? Well, in the free body diagram, I drew two. I drew an applied force up and the gravitational force down. So since one was up, one was down, I would say Fa minus Fg equals ma. And then I can take this one more step, because they didn't give me my weight. If they'd give me my weight, I would just change Fg to my weight. They did give me my mass, though, so I'm going to take Fa minus mg equals ma. And now I can start plugging in numbers like they gave us. So Fa is what I'm looking for. M, they said, so it's a 2 kilogram physics book. G is 9.8 meters per second squared. Now, on the last problem we just did, I made that 9.8 negative. So why am I not making it negative here is because I already did. When I said minus mg, I already accounted for it being downward. So you don't want to do it again, or it'll cancel out and then it'll mess up the problem. The two forces were not up. One was down, one was up, so you make it negative. Over here, I got 2 again, and then I got to ask myself what the acceleration is. If they didn't give it to me, maybe they gave me other information to find it. But in this case, they gave it to us, and then direction is important, downward. Since I defined down as negative, I'm going to have a negative here as well. If I accelerated it upward at 1.5 meters per second squared, then I would have made it positive. And this, you experience this anytime you're lifting weights. They say you're cheating. As long as you're pushing, let's say you're doing a bench press and you're just lifting those weights at a constant speed, you're lifting the actual weight. If you do any type of jerking motion, even jerking it up or letting the weights fall, then you're messing with the acceleration, which is going to mess with the force that you have to apply. So if you drop the weights while you're lowering them, not completely drop, don't let go, you just kind of let gravity help you, that's when you're cheating. You've lessened the applied force, because here's what's about to happen. We're going to add this 19.6, right? 2 times 9.8 is 19.6. Again, you don't have to show math. Obviously, you should write it out for you, but you could do that on scrap paper. But I would add 19.6 to the other side, to that negative, and I'm going to get... So I'm going to get 16... Sorry, guys, 16.6 newtons. And then if we do a quick conversion to pounds, it's about 3.7 pounds. Now, 2 kilogram book is closer to, if you just found its weight, it's 2 times 9.8, it's about 4 pounds. So why is this weighing less? Because we're letting it drop a little bit. So we're cheating a little bit there, and that light Newton feels like it's lighter. Like we don't have to apply as much forces to hold it. The only thing I'm going to mention about these force problems is AI likes to set these up in silly ways. You have to set it up like the free body diagram is going to show. Like I'm showing you right here. You're going to have forces summed up on one side, and that's going to equal MA on the other side. Then you're going to put in the numbers like it says to put them in. Then you can do whatever you want. But you got to show me you know how to set it up. You got to show me you know how the forces add, subtract. Real quick, sigma does mean sum. So you will see some instances where it's Fa plus Fg. I'm okay with that, as long as now down when you go to fill in the numbers, you would make 9.8 negative. So just be careful with these and ask questions.